I wasn't quite sure what you wanted me to talk about, so I'm going to show some projects that I'm working on. And right now, this is the Green Hospital that I'm designing in London, called the extension to the Great Ormond Street Children's Hospital. The extension is that small part of the site, which is in the Blue Street area. And here it is. The idea was to make this a low-energy building, and we have a flue that brings in, that makes the ground floor and the first floor to natural energy to reduce the energy consumption. Here it is under construction, and you can see the flue on the left-hand side, and the ground floor is a cafe, which will be operated by Disney because it's a children's hospital. Here's another view of the building under construction, looking at the corner from Guildford Street. These are some of the green systems we used. The buildings we rated BREEAM Excellent, which is 78 points. BREEAM is the UK equivalent of E, and that another 7 more points could probably be the greenest building in the UK. This is the integration of the physical aspects of the hospital design. There's a cedar roof on top of the building, of this extension. Now, let's not look at energy consumption in different building types. What I found is that hospitals actually isn't that high energy, but it is still very high energy buildings. So this is the idea where we drove our scheme to have a flue at the corner of the building so that the lower ground floor and the ground floor and the first floor can be naturally ventilated, and this reduces energy consumption for the building. This is the energy part of the building, and this is the view of the CO2 emissions. And this is different strategies of building. Interior, because it's a children's hospital, we wanted to reduce the stress of the children when they enter and use the building, and when they enter, when they go between each of the facilities from the wards. Stress-free environment for them. This is some of the studies of the building. That's the equipment used. That's green materials. And this is integration with the clinical aspects. I thought I might show a green retail complex that I've designed. Our design actually starts with not just looking at the green aspects, but looking at how we can reduce the use of air conditioning and heating. So this is, if you like, my method for designing low-energy buildings. We start from passive mode to mixed mode to full mode, productive mode and composite mode, and at each stage you try to optimize the energy consumption. Passive mode means no mechanical electric systems. So when we design a building, the first thing we do is how can we design it in such a way that without the use of any mechanical electric systems, it is low energy. That means the shaping of the building is important, the orientation of the building is important, the materials we're using for start is important, and the materials we're using the roof is important. The use of the climate of the place is important. How can encourage natural ventilation and so forth without use of mechanical electric systems. But you look into the traditional architecture of your country, of anybody's country, and here the traditional architecture, for instance, could be the Incan architecture, you find that they already do it. They already have designed low-energy buildings in a passive way, intuitively. You don't have to work it out the same way we have. But if we study traditional architecture, we can learn a lot about passive systems. The second mixed mode means some mechanical electric systems. So for instance, the use of ceiling fans, the use of evaporative cooling. For instance, you have several climatic zones in Peru, and for instance, you can use a flue to try and suck the air and to increase the natural ventilation of the building. Next is the mixed mode, and so we should try and find out which areas we can use the mixed mode. And then full mode is the mechanical electric systems, how we can make this low energy as much as possible, using automation systems, using sensors. And finally, productive mode is the use of renewable sources of energy like wind energy, using solar energy, hydroelectric energy. And composite mode is to try and have a system that relates to different seasons of the year. And so designing a low energy building is actually optimizing each of these modes as you go from passive mode to mixed mode to full mode to productive mode and then the composite mode. So if you like, this is a formula that I use for designing a low energy building. And so for passive mode, we go to mixed mode, And here's an example of a retail where we optimize the mixed mode by reducing the need for air conditioning. This is the retail complex that we finished about a year and a half ago. It has a podium of retail with 2 residential towers on top. The retail actually consists of 3-story shop lots with a canopy on top. And the canopy is an air gap between the shop houses and the canopy. Now the idea of this retail is that they are double shop houses. So when you sell a shop house, you sell 3 floors of retail already. Otherwise, you have conventional retail, then it could be maybe 300-400 shop lots, so you have to rent a seller. But here you're talking about 90, and if you sell 90, you sold retail. So this is something you need to think of. It could be an idea that you could use for your retail projects. So that's the typical shop lot that we sell. What you sell. But in the middle retail, above the canopy, we have a skylight, and within the skylight we have turbines that suck the air out. So that the public areas for this retail is not air conditioned. It's totally naturally ventilated, and the natural ventilation is affected by these turbines. So these are the 3 turbines on top of the retail canopy, and you can see the turbines from the retail looking out. Now we started to simulate the comfort conditions, and so these are some of the simulations that were done. On the blue curve shows the actual public areas, and then the crosses show where the turbines are, and this shows the comfort conditions when you switch on and when they're off. Now above the retail are the apartments, and what we want to, and this is a number of apartment units per floor, about 6 per floor. But the biggest problem with apartment design is how to ventilate the back of the apartment without using any mechanical ventilation, mechanical systems. And so behind the apartments we have a number of voids, and these voids, if you like, go all the way up to the top of the building, and we wanted to bring the wind in to try and cool and ventilate the back of these apartments. So this is a view through a corridor showing the voids that are used to cool, to ventilate the back of the apartments, which means the kitchens, the toilets, and the bedrooms. This is a simulation of the comfort conditions at the back to show that it worked. And so, now we also studied the sun shading for the building. And this diagram, the graph shows that if we did have sun shading, this would be the heat that enters the building. The sun shading, this is the comfort condition in the building. So sun shading actually contributes in the summer towards making the spaces comfortable with the use of any air conditioning. Here's an office building that we just completed end of last year. It's received a number of awards. It's rated Green Mark Platinum. And this week it received one of the Holcim Sustainability Awards. This is the Solaris building in Singapore. And this is the building form that was given to us. The original master plan was done by the Iraqi architect Sahara did, and each corner of the building had a different height, and so if you like, the final configuration optimizes the permissible building envelope. That's the building which is completed, right next to the park on the left-hand side, and then this is the north area of Singapore. You can see the roof gardens on top of the roofs, here, 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 and here, and the green terraces at these corners. Now these are, if you like, I call it the linear park. Now I'll explain this to you in a minute. This is the roof garden at the utmost top of the building. This is the facade. Now one of the requirements in Singapore is that the ground area, the ground coverage, has to be replaced within the building. Now how to achieve this without losing gross floor area became a challenge for us. So we captured the building envelope and wanted to bring the vegetation into the building to replace it within the building. And so the idea that we had was to have a spiraling ground with vegetation on it, and this hangs on the outside of the building. We call this a linear park in the sky. And then we stretch it out, and it's about 1.3 kilometers long. But where the linear park hits the corner of the building, it opens up to become a terrace, so that people use the linear park and the inside of the building could interact. And you can see people put tables and chairs there, and people have breakfast or people have lunch there, have tea there, and of course smokers can go up there to eat. And you can see the vegetation on the right hand side. And so these corners punctuates the linear park. Every corner opens out into a terrace. And that's the lower roof terrace. Now, one of the questions I get asked most is, does the green building cost more? For this project, which is a 550,000 square meter building, the energy savings in water and electricity and energy is about 530,000 US per annum, which is almost 70 cents per square foot. And so this is possibly one of the greatest justification for green buildings. That the green building will save energy and water, but not only that. Estate agents tell us that a green building will appreciate in value much more than a non-green building. Now you put yourself in a position that you have two buildings to buy. One is no energy savings, no energy water, and one is a significant savings in energy water, because it reduces the service charge to your tenants and to your purchasers. And of course, does it cost more? This building achieved Green Mark level, which is the highest level of green rating in Singapore. And this was at 6.5% for the industry standard for this building type. And so our cost consultant tells us that we should budget between 4 to 8%. And so a green building, besides giving savings, costs a little bit more, but you know that within 5 to 8 years, you get this back through amortization. The building has a central atrium, which is naturally ventilated and has operable glass louvers on the top. And the louvers open and shut automatically, so that when on a good day it opens up so the air can go out, if it rains, it automatically shuts. And the building's actually, so this is the detail of the operable glass louvers, which opens and shut automatically. The building actually consists of two blocks which are linked by bridges. This bridge is linked with two buildings, and this one of the bridges looking down into the plaza below. Now things happen very fast in Singapore. We designed it in December 2007. There was a competition by the client to compete for the land, and so they submitted it for the land with us with our design. They awarded in March 2008, and within 3 months we started construction. So we designed construction. This building, we were finishing our drawings, and the building was completed in 2010. The building practiced recycling materials, waste materials on site, and recycling timber formula for the concrete construction. There's another building that we did in Singapore, which is the Green Library. This is the National Library in Singapore. And again, this is the Green Mark Platinum building. It's quite a large building. It's about, the total construction cost is about 400 million Singapore. And this is the model of the roof showing the infrastructure where we could put in photovoltaics at a later date. This is looking to the National Management Atrium in between the two blocks. This is the ground floor, which is open to the sky, so that the concrete mass of the floor above the ground floor provided cooling, evaporative cooling to this plaza in the early hours of the day. Because the red rectangle shows where we call it eco-cell. These eco-cells bring vegetation down into the inner parts of the building, and this is the view of the eco-cell from the ground floor. And it actually brings daylight into the basement, which is actually quite a nice space. The floor plans of the buildings, because it's basically 2 blocks, which are linked by bridges. A straight block is where we have the book collections, which is based on a 9-meter regular grid. On the right-hand side is the programming block, which is where the poetry reading, the exhibitions, the seminars take place to encourage people to come to the library, and then literally they're brought across the bridge to try and to get interested in reading and in the knowledge-based country. And so I'll just show you some of my projects, show you an approach. creating a framework for looking at redesign. This is only the tip of the iceberg of what we do. I've been doing redesign for nearly 40 years now, and that for me is still very much what to do. And before I start pushing daisies. Thank you very much.